All right, today we are going to be focusing on multiplying two-digit numbers with area models. So before I teach you the standard algorithm, we're going to break it up kind of like expanded notation sort of, which is why we started with place value at the beginning of the year this year. You've got to have a solid understanding of place value. You've got to have a solid understanding of place value for so many different things, this being one of them, okay? So today in our notes, we are going to be using area models where we're breaking up numbers into their place value and what each digit is worth. If I can get it straight, that would be lovely. There we go. Okay, so multiplying two-digit numbers with area models. An area model, what is it? It is a visual, remember if I write, you write. It is a visual representation of multiplication the factors are the length and the width. This sounds weird, but you'll see what I mean in a minute. The product is the area. Okay, so we are going to look at a few different things. We have some steps. We have some steps below where it says steps 1, 2, 3, and 4. So we're going to be focusing on this section first. Step 1 says write the expression using expanded notation. So what does that mean? I'm going to break apart each of these numbers into expanded notation. So if I am trying to figure out what the 3 is worth, first I have to know what place the 3 is in.
Tens.
It's in the tens place. So if I have 3 tens, how much is that equal to?
30.
That is equal to 30. So I'm going to put 30 here. Plus, how many ones do I have in that number?
1, 6.
6. Okay, so I put a 6 there. Now, I want to figure out the same thing for 23. So if I have 2 in the tens place, that means it's 2 tens, which is worth how much? 20. And how many ones?
3.
3. Okay, so this is kind of how we set up an area model. So we've labeled the blocks. We want to find the area of each block. Do you remember how to find area? Area of like a square or rectangle, do you know how to do that? Multiply them. Yeah, length times width, okay? So I'm going to find the area of each square. So to find the area of this first square here, I'm going to multiply which two numbers?
30 and 20.
30 and 20, very good. So I'm going to do 30 times 20, which equals how much?
60.
60?
No.
How many zeros do I have?
2.
2. So,
600.
600. Very good. Okay, now if I want to find the area of this square over here, I'm looking at the 30, but I'm also looking at the 3. So 30 times 3, which is how much?
90.
Very good, smarty pants. Okay, now I'm going to find the area of this square down here. Oh, that one's sloppy, sorry. Okay, so I'm focusing on this number 6 by what other number?
30. 3. 20.
20, because it's up here measuring this distance. So I'm doing this times this. So 6 times 20. So we're going to write 6 times 20, which equals how much? 120. And then my last square is going to be over here.
And you're adding.
Am I adding? I'm still multiplying. I'm still multiplying 6 times 3. Thank you, Isaiah. Very good. And that is 18. Okay, now I'm at step 3. Somebody was jumping the gun a minute ago. Add all of the areas. So once I add all of the areas, that's going to equal my product. You're writing the word product in the blank there. So when you add all of the areas together, I'm taking 600 plus 120 plus 90 plus 18. Yes, we are adding. So in the ones column you have an 8.
28.
So in the ones column I have an 8.
1,800.
In the tens column, what digit do I put down here at the bottom? Whoops.
Who's leaving? 12. Or 2.
How much? Yes, I put a 2, carry the 1, and then in the hundreds column I have a what?
8.
8. So 828 is my sum, but it is also my what?
Product.
My product. Very good. That's okay. That's okay. Okay. So you guys just did a 2-digit by 2-digit multiplication problem without doing it the standard algorithm way. Okay, we are doing the standard algorithm way, and I'm going to let you choose which one you like best. We're doing standard algorithm tomorrow. Today is all area model, breaking it up with expanded notation. Okay. Now let's look over to the right where it talks about perfect squares. Perfect squares are things like 5 times 5, which is 25, or 10 times 10, which is 100. 12 times 12, which is, oh, you guys are so smart. 4 times 4 is 11 times 11, 121. 15 times 15,
130.
more than 100.
130.
Nope.
200.
225.
Oh, yeah.
So if you don't know how to do that, how could we break up 15 and 15? Do you see my area model right there?
5 times 5 equals 25, and then 1.
But how would I think about how I broke up the numbers to the left? See, 36 and 23 in an area model. I did 30 and 6 and 20 and 3. So how could I break up 15 and 15?
1 and 5.
The 10.
10.
Top left corner.
And plus how many ones? 5.
5.
And then again 10 plus how many ones? 5. So then we can do 10 times 10 for this first square, which equals how much? 100. Now for this square over here, I want to do 10 times 5, which is how much?
50.
For the bottom left corner, right here,
25.
10 times 5, which is
50.
And then the last one, I have 5 times 5, which equals,
25.
and if I follow my steps that we just did a second ago, we're going to do 100 plus 50 plus 50 plus 25, add it all together, and you get 225. Okay. That is how we use area models when multiplying 2-digit numbers. Now, look at the page next to your notes. We have our practice. So right over here. Number 1, and we're going to cubes it. We are always cubesing our problems because we're getting in the habit of problem solving and using problem solving strategies. So I want to circle all of my numbers.
23.
Henry helps his dad install new tile in his bathroom. There are 23 rows of tile with 35 tiles in each row. So I have 23 rows
That's 35.
And each
and 35 in each row. How many tiles did Henry and his dad install? So what am I doing? I'm
35.
multiplying 23 times what?
35.
Right. To do an area model, I'm going to draw myself a box. I'm going to divide it into 4 parts. Okay. Now I want to break up each of these numbers. So let's look at the first number, 23. How do I break up 23? How many tens do I have?
20.
I have 2 tens, which equals 20, right? Okay, so I'm going to put 20 here. Plus 3 ones. Now, could I have done that vertically? Could I have put 20 here plus 3?
Yes.
Yeah, I could have. It doesn't really matter where you put it. Okay, next I'm going to do 35. So I need to break up 3 tens, which is worth how much?
30.
30. Plus how many ones?
5.
5. Okay, now I can multiply. So I'm going to do the top left square first, where I'm multiplying 20 times 30, which equals 600. Next to that, I'm going to do 30 times 3, which equals how much?
90.
90. And the bottom left, what 2 numbers am I multiplying?
5 and 20.
Right. So 20 times 5 is equal to how much?
100.
100. And the last one is going to be 5 times 3, which equals,
50.
okay. Now what do I have to do with each of those?
Add them all up.
Yep, I got to add all 4 of these together. So I have 600 plus 100 plus 90. I don't know why I'm writing a plus sign every time. Don't need to. Plus 15. Okay, so I add up my ones column, and what do I have in my ones column?
5.
Good. In my tens column, I put a 0 and carry the 1. And then in the hundreds column, I should have 8. So my answer is 805. Thumbs up if you're starting to get the hang of this. Thumbs sideways if you're still getting there. Okay. Okay, good. Okay, let's look at number 2. It says this area model represents which expression? Okay, well, remember, it's broken up into expanded notation or expanded form. So if I'm looking at this, I have 50 plus 7. So I have 50 plus 7. How much is that together?
57.
57. Okay, and over here I have 30 plus 6. So what is that?
36.
36. So which one of these problems has 57 plus 36? Is it A? Definitely not. B? We're going to put a question mark by it because I hear yes and no. C shows me 30 times 50
No.
plus 7 times 6. Okay, well, if I did 30 times 50, that's this box here.
Wait, you said plus.
Uh-huh. Plus 7 times 6, which is only this box. It's only that box. Do you see anywhere where I'm also doing 30 times 7 plus 6 times 50? Because I have to have all 4 boxes that I add together, remember? Do you see all 4 of those in C? Or just 2? You only see 2. You see 50 times 30 here, and you see 7 times 6 here. We're missing these pieces, so C is out. It cannot be C. Okay, what about D? I have 30 times 6. That's not even an option on here, so that's just all kinds of wrong. So B is the correct answer. And then the last one. At the school assembly last week, there were 49 students in each of the 24 rows in the auditorium. How many students attended the assembly? what is my problem going to look like? What am I doing in this problem? Good. 49 times 24. So we draw our area model. That's too big. Draw a smaller area model. Okay. Remember, divide it into 4 sections. Okay. Now, at the top, I want to break apart 49. So how many tens are in 49?
40.
There are 4 tens, which is equal to 40, right? Okay, this time I'm going to put this on the side. So 40 plus, how many ones?
9.
Good. Okay, now at the top, I'm going to do 24. So how many tens in 24?
20. 2.
2, which is worth how much?
20.
20. If I have 2 tens, that's equal to 20. Plus how many ones?
4.
Good. Okay. So we're going to solve this box first by multiplying what 2 numbers?
40.
40 times 20, which is equal to
80.
800. Very good. Okay, now we'll do this box over here. So what 2 numbers am I multiplying? 40 times 4, which equals 160. How am I doing that so fast? I'm looking at 4 times 4, which I know is 16, and then I just put the 0 at the end.
And 20 plus 9.
Okay. 20 plus 9,
20 times 9.
20 times 9. So down here in the bottom left, I'm doing 20 times 9. What's 9 times 2?
18.
18. Put the 0 at the end. So 20 times 9 is 180. Then my last one is 9 times 4, which is equal to
36.
36. Okay, what am I going to do with all of those numbers?
Add them all up.
Yes, ma'am. 800, 160, 180, 36. We add our ones column, which equals what? 6. Okay, set it on the floor, please. Thank you. Tens column.
17.
Very good. And hundreds column.
11.
11. So A is my correct answer. You guys are a bunch of mathematician geniuses.